Hello everyone. Today we will be viewing design and implementation of combinational circuits using Verilog. So, introduction. This presentation covers the design and implementation of combinational circuits using Verilog. We will explore fundamental concepts, methodologies, and practical applications that highlight the importance of these circuits in digital systems. So, what is Verilog? Verilog is a hardware description language, also known as HDL, used to model electronic systems. It allows designers to describe the structure and behavior of circuits, enabling simulation and synthesis of digital systems efficiently. Verilog syntax basics. Understanding Verilog syntax is crucial for effective design. Key elements include modules, assignments, and always blocks, which define how circuits operate and interact with signals. Basic syntax of Verilog code constructs. Verilog module syntax. Keyword module and in bracket input ports and output ports, which is internal logic, and then keyword end module. For input and output declaration syntax, if the wire is single bit input, then input and name of the wire. If it is multi-bit input, then input and wire name, and in square brackets, it will be number of wire uh, colon 0. Same goes for output wires. Modeling styles in Verilog. There are four types of modeling styles. Gate level, designing basic gates, which is primitive initiatives. Data flow, designing using logic equation or Boolean expressions. Behavioral, designing using high-level constructs like loops, delays, case, function, and if else. Structural, designing using smaller modules or instances and Verilog primitives. Gate level modeling. Syntax. So keyword gate, primitive name, and in square bracket and in round brackets, output, and if and the number of input. So for example, NAND gate. NAND is the keyword. Primitive name is N1 or the component name is N1. So NAND gate has two inputs and one output. Therefore, in round brackets, one output and input 1, input 2. Similar for XOR and NOT gate. Data flow modeling. Syntax. Assign net expression equals expression of different signals or constant values. For example, assign C equals A and B, which is for AND gate. Combinational circuits overview. What is combinational circuits? Combinational circuits are logic circuits whose output depends solely on current inputs. They do not have memory elements, making them essential for operations like addition, subtraction, and multiplexing. Key components of combinational circuits. Common components include logic gates, adders, subtractors, and multiplexers. Each component plays a crucial role in processing input signals to process the desired output without memory. Designing combinational circuits. The design process involves the truth table, deriving the Boolean expression, and implementing the circuit using Verilog. This system approach ensures accurate and efficient circuit design. The following is the diagram for combinational circuit. Combinational circuit example. An example of combinational circuit is a 4-bit binary adder. In Verilog, this can be implemented using simple modules that define the addition logic and output behavior. The following is the logic diagram for the following is the circuit diagram for 4-bit adder. So C0 is the input from the component, which is given to the first full adder. The sum is S0 and carry for the first full adder C1 is the input for second full adder. The sum is S1 and the carry of second full adder C2 is given to the input of third full adder, which is full adder. The sum is S2 and the carry of third full adder C3 is given as input to the fourth full adder, and sum is S3 and the out carry of fourth full adder is the final output C4. Similarly, for the respective full adders A0, A and B are the input wires. This is the circuit diagram and truth table for the same. Example of four. So here for the Verilog code, here keyword module and primitive name full adder. Here the input wires are A, B and Cn. Full adder requires 3 input and output wire is sub and carry. So assign sum A XOR B XOR Cn, which is the basic Boolean expression for the adder, and Cout, which is carry, as A and B or A and Cn or B and Cn, and keyword end module. For module, again keyword module for adder 4-bit. For the component, here input wire, since this has multiple input, multi-bit operation, then input wire square brackets 3:0 A and B. So here 3:0 indicate signals are 4-bit wide, which is A0, A1, A2 and A3 respectively with B. Input wire Cn, and same is the code with output wire, uh, bracket closed. And then we'll declare the signals, which are C1, C2, C3, the internal carry wires. Then we will be initiating the 4 full adders. 4 full adders. Full adder, the component name, the basic component name, and the FA0, which is the declared first full adder in the circuit diagram. So here, this local A is given with is connected with A0, B is connected with B0, Cn with Cn, sum with sum0, and Cout with C1, respectively. The rest are done. And then end module. Simulation in Verilog. Simulation is a key aspect of Verilog design. It allows designers to test and verify the functionality of circuits before implementation, ensuring correctness and performance. This is the testing and validation. This is a test bench for the Verilog code. Common challenges. Designing circuits using Verilog can present challenges such as timing issues, synthesis discrepancies, and debugging complexities. Understanding these challenges is essential for successful implementation. Conclusion. In conclusion, the design and implementation of combinational circuits using Verilog is fundamental in digital electronics. Mastery of these concepts facilitates the creation of efficient and robust systems. Thank you.